Okay, let's look at alpha decay. We'll look at the different types of decay that particles undergo, or that nuclei undergo. So first of all, you just need to know what an alpha particle is. An alpha particle is a helium nucleus. Um, it consists of 2 protons and 2 neutrons. It has no electron and a charge of plus 2e. So we would give the notation of this alpha particle as a helium with 4 nucleons, 2 protons and 2 neutrons, and 2 protons. Um, Sometimes we'll use an alpha letter instead of using the helium, so we'll use a letter like that, but it will always be implied that it will have this notation. So usually we'll use this to represent the alpha particle, but always understand that I have 4 nucleons and 2 protons for A and Z. So that is the alpha particle. Let's look at some examples, and you'll have to do these on your exam. And those conservation rules are going to be really important, that I have to conserve the number of protons and neutrons in the parent nucleus when I move to the daughter nucleus. So let's look at alpha decay occurring for plutonium-242. Pu uh, is the symbol for plutonium, and if we were to write 242, Pu has a value of Z equal to 94. That's the number of protons, and then 242 is its atomic mass. So it has additional neutrons. So plutonium-242 will undergo alpha decay. That is, it's going to have some daughter nucleus plus an alpha particle, which would be alpha 4, 2. And so we can imagine what that's going to be. Well, if I have 94 right here, and I have 2 right here, then I'm going to have a value of Z for 92, and I'm going to have 238 here. I want you to notice that these 2 numbers add up to equal this number, and then likewise these 2 numbers add up to equal that number. And if I look on my periodic table, then I will see that the new element that's created with 92 new protons is going to be uranium, or U. So look at our rules here. Rule number 1 is that 242 has to equal to 238 plus 4, that the atomic mass of the the atomic mass of the parent nucleus has to equal the atomic mass of all the results from the decay, the daughter nucleus plus the alpha particle. And then rule number 2 is that our number of protons also has to be conserved, so 94 is equal to 92 plus 2. Those are really the only things that you're looking for, is that you have conservation of these particle numbers. Let's look at radium-226. So if I have radium-226 that undergoes alpha decay, let's see if you can identify what the product is going to be. I'm going to have my helium atom here. It has 4 and 2. And so what is going to be my new particle? Well, over here I'm going to have 86. And here I will have to have 222. So if I look at my periodic table, number 86 is Rn for radon, and I can look at my rules. 226 equals 222 plus 4. So this is going to be radon 222, by the way. And then rule number 2 is going to be 88 equals 86 plus 2. All right. Alpha decay is not terribly complicated. You just try and applying these two rules that I have conservation of these numbers on either side of the equation.